Hello, if you're watching this video, it's because you were absent today. In class, we went over box and whisker plots, which is another way of displaying your data so that you can accurately understand what happens the most often. And we're going to be using the median a lot when we create these box and whisker plots. Box and whisker plots always have this rectangle, and then they've got these are called the whiskers, the ones that stretch out from this rectangle. Let's watch the beginning of this video and go over one of the examples so you can see what I'm talking about.
What's up, everyone, and welcome to this lesson on box and whisker plots. Now, from your experiences as a math student, I'm sure that you've come across different methods of visually representing data. Pie charts, bar graphs, and scatter plots are a few examples of these tools. Box and whisker plots are another method of visualizing data to help.
Try to make it bigger.
Basketball player. Box and whisker plots are another method of visualizing data to help us to make sense of it, and that is what this lesson is going to focus on. So again, a box and whisker plot is just a tool that's going to help us to analyze data. So first, we need some data. So let's look at Jordan, a JV basketball player who was just called up to varsity for the last 7 games of the season. So Jordan's using this chart to keep track of the number of points he scores for each of these 7 games. Now we can use this performance data to create a box and whisker plot that will help us to evaluate Jordan's performance over this 7-game span. Now our first step is to take those numbers and rearrange them in order from least to greatest. Now the first piece of information we can get from this data is what's called the upper and lower extremes. This represents the highest and lowest value in the data set. In this case, the upper extreme is 32 and the lower extreme is 5. The next piece of information that we need is the median. Now we know that the median is the middle of the data set, so I work from the outside in until I get to the middle value. In this case, 17 is the median. And the final piece of information that I need is what's called the upper and lower quartiles. Now we can think of this as splitting the data set at the median into an upper and lower regions. Now the upper quartile is just the median of that upper region of 3 numbers, which we know is 20, and the lower quartile is the median of that lower region of those 3 numbers, which we know is 10. So we can say that the upper quartile is 20 and the lower quartile is 10, and now we have all the information that we need to construct our box and whisker plot. So we're going to start with a number line that fits our data, and we have to mark where our upper and lower extremes are at 5 and 32, as well as our median value at 17, and the values of the upper and lower quartiles, in this example at 10 and 20. Now imagine taking these points and elevating them above the number line. Our first step is to construct 2 vertical lines through the upper and lower quartiles, and use these lines to construct a rectangular box that encloses the median point. And through that median point, we construct a vertical line. This represents the box in our box and whisker plot. And the final step is to draw horizontal lines that connect the upper quartile to the upper extreme and the lower quartile to the lower extreme. And notice that the graph itself is broken up into 4 different quadrants, each representing 25% of the whole. Now what you're probably thinking is, how can we use this graph to evaluate Jordan's basketball performance? Now, for example, by looking at the extremes, we could see that it's probably unrealistic to expect Jordan in an average game to score anything near his high of 32 points or his low of 5 points. Now, based on those extremes, you may think that Jordan is an inconsistent player. But if we look at the area inside the box, this is called the interquartile range, we can say that in an average game, Jordan will score between 10 and 20 points.
Okay, so what this is saying is that we are taking a look at, let me grab my pen here, what Jordan does in a regular basketball game. And what we're going to say is that he usually will score between, what is that, 10, I'm going to say, and 20 points in a game. This is what normally happens. This is 25% of what he does. Here's our median. So this is the other 25% of what he does. This is 25% of what he can do. And this is 25%. Quartiles means we are splitting up what he can do into quarters. He will usually play in this range. He's had a couple of really awesome games. He's had a couple of stinker games, but generally speaking, he will be in that box. And what this is saying then is you can compare to other players. Let me click play on this.
And a coach can use this information to determine whether or not Jordan belongs in the starting lineup or on the bench.
Come on!
He can also use the box and whisker plot to compare Jordan's performance with the performance of other players.
So this right here is Jordan. This is another player. And this other player, 50% of the time, will score more points than Jordan. His median is higher, and this 25% of what he normally does is higher, even though his extremes are not as extreme as Jordan. So I would probably put this new player out there in the starting lineup and not Jordan, because he will regularly score more points than Jordan. And that's what we use box and whisker plots for, is comparisons. So grab a piece of paper. We are going to work through these notes, and you are going to be building box and whisker plots and practicing box and whisker plots. All right. Sorry about that. Here are the notes we took in class today. And we pasted these into our comp book with a title of box plot. So on your paper, go ahead and have a title of box plot. And you're just going to have to work through this with me without these guided boxes. The first thing we need to do, step 1, is to put our data set in order from smallest to largest. So we're going to go through, I'm going to scan through here, and I think 3 is the smallest number in this set. So you're going to write a 3, cross off this number. Here's another 3. So keep up with me as I write this data set out. I have a 4. Here's a 5, and here's a 5, so I have 2 5s. No 6s. Here's a 7. Here's another 7. I have an 8. I have a 9. I don't see any 10s. I do see an 11. 12. Here's another 12. 13. Here's another 13. Here's a 14 and a 19. And then what I want to do at the end is I want to count and make sure I have the same numbers that is in the list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let me figure that out. Okay, it looks like I missed this 16 right here, so I'm just going to add that in. So that, friends, is why you always want to count to make sure you have the data set organized correctly. Now I have 17 and they have 17, so we're good to go. I'm going to find my median first. Well, actually, what I can do is I can find the minimum and the maximum first. My minimum is 3, and my maximum is 19. Now I'm going to find my median first. I'm going to use a different color for this. It's not 3, not 19. Just put a slash through this because we're going to need these numbers later. We need to be able to see them. So you're going to go through and you are going to slash out until we get to the middle. And I can see that my middle is 9. My median is 9. That's my 50% mark in my box plot. What I need to do now is essentially what I'm doing is I found my half point. I need to find my half of half. So I'm going to find 1/4 over here, and I'm going to find 1/4 over here. That's the quartile part of this interquartile range. So from 3 to 8, rather, I'm going to find the median of this section, and I'm going to use an opposite slash, not 3, not 8. Not this 3, not this 7, not 4, not 7. What I'm left with are 2 5s. When you have two numbers and you're trying to find the median, you do 5 plus 5 and divide by 2. 10 divided by 2 is still going to be 5. So my Q1 number is going to be 5. I'll do the same thing on this half of my data. Not 11, not 19, not 12, not 16, not 12, not 14. I have 2 13s. Pretty easy. This is going to be 13. Sometimes you may have something like 7 plus 8, which is going to be 15 divided by 2, which will be 7.5. That is okay. You can have a decimal. It's just on your number line, you've got to line it up so it's at 7.5. In this case, it's a little bit easier for us. So now I know 1/4 of my data is from 3 to 5. 1/4 is from 5 to 9. 1/4 is from 9 to 13. And my last fourth, or my last quarter, is from 13 to 19. My next step then is to turn this into my box and whisker plot. And in your notes, this is going to be a whisker. Your maximum is going to be a whisker. The Q1 and Q3, this is your box and this is your box. Meaning, I'm going to create a rectangle from 5 to 13. So make a number line. Pause the video, make a number line like this one. And then you're going to draw a rectangle that goes from 5 and stretches to 13. Perfect. This is 50% of my data. It goes from this quarter all the way to this quarter. 50% of my data is found in this box. My median, I'm going to mark with a line at 9. So this is my median line. And then finally, I'm going to do my whiskers. I'm going to go from the box over to 3, make a dot, and from the box over to 19. Got it. I had to really look at that. Okay. That's your box and whisker plot right there. Your range, we've done this before. Your range is your maximum number minus your minimum number. So your range is going to be 19 minus 3 equals 16. The interquartile range wants to know this range. So that's going to be your Q3 number minus your Q1 number. In this case, this is going to be 13 minus 5, 12, 11, 10, 9, 8. Our interquartile range is 8. And that, friends, is how you do a box and whisker. What you're going to do now to practice is go to this learning activity, box plots. Same thing, box and whisker or box plot. It is a slideshow that looks like this. For each of these problems, there's 4 on this slide, 4 on this slide. You're going to have to make sure your numbers are in order. This first one is, after you get to numbers, as soon as number 2, it stops being in order. So you have to put your numbers in order first, always step 1. Then you are going to find your median. I'm going to mark this out. Not this one, 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 not this one. It is 2. My median is 2. I can see that my interquartile ranges, I'm going to have a 1 and a 3 because it's in between the rest of my data. Now, what I'm going to do is grab a box and I'm going to drag it up, and my box is going to go from 1 to 3. So I'm going to grab it and I'm going to shrink it. My median is 2, so I'm going to grab my median line and I'm going to put one right here at 2. And then I need my whiskers, but my minimum is the same as my interquartile number, my Q1 number. So I don't need a whisker on my left side. I do need a whisker on the right side. So I'm going to grab one, I'm going to put it up here, and I'm going to shrink it down to 7. So sometimes when you do these, you will have only one whisker. So now I have my box, my median, and my whisker showing my maximum number. You are going to do that for the rest of these. Remember, if you have 2 numbers in any median or interquartile number, you add them together and divide them by 2. It is okay to have decimals. If you have any problems, email me.